So good morning and welcome to my session on AI agents in depth. What we're going to be looking at in this session is function calling, model context protocol, and tool usage. But we're going to go a level deeper. And what really interests me is how the models actually understand to make the decisions on tool calling. How that's influenced through the system prompt, the user intent, and the tool definitions. And also, things that can go wrong with tool calling. There's this kind of old adage, if your only tool is a hammer, you see every problem as a nail. And the large language models can, very often use the wrong tools or put an overt amount of trust in the responses of tools. So what I'm going to be doing, the demos are not going to be really complex, but what I'm going to be kind of showing is how the models kind of infer what to use the tools. And if we understand that, we can build better solutions. I'll round off as well, I don't know if you're in the previous session, but there's some great tips on me using Claude Code and how we can customize that. I'll look at how once we've got an understanding of agents and tools and skills, we can start to customize our copilots to be able to do things for us, automate stuff. And I've got some examples of that, how we can use those types of skills there. A bit about myself, my name's Alan Smith. I'm from England, I live in Stockholm. I've been writing code for money for about 30 years. I've been standing on stages and talking about stuff for about 20 years, do quite a lot with the community. I'm in the MVP program, which I've been in for 20 years in a number of different technologies, currently with the AI Foundry technologies. And that's an award for just, standing on stage and talking about stuff. It's not really about, having knowledge of stuff. It's really about just sharing ideas. Best way to contact me after the session is on LinkedIn. I'll give you the details. I will be around here for questions after the session as well. In my free time, I DJ with code using something called Sonic Pi. I'll talk about that a bit later on because I'm using Agentic AI and vibe coding to create software that helps me with that. I also like to get out in the short summer that we have in Stockholm on my windsurf and paddleboards. So I've also delivered a session on Inside GPT and basically how the large language models work. So basically, a large language model uses the generative pre-trained transformer, which is an architectural pattern. All of the LLMs use this type of pattern or something similar, not just the GPT models, but basically, given a sequence of input tokens, a large language model will predict probabilities of each token being the next in a sequence of tokens. So if we feed in 1 plus 1, the large language model will do like 5 trillion floating point operations, and it will predict that the answer is probably going to be 2. And that's going to be the most likely token. When we get into Agentic AI, if you've not kind of built one of these AI agents and not played around with the code, you kind of have this mythical understanding of what the agent does. You have the user who goes in and they download the latest version on the mobile phone app, and it's now been updated and it's agentic and it's got all of this AI-assisted functionality. And behind the scenes, there's some AI agent application. There's a genie inside there that can understand the user's intent and do stuff for you automatically. That's basically how it seems. But under the hood, we really want to understand about what happens in an agentic application. So the user asks a question like, what's the weather like in Oslo? That goes into the agentic application. And the agentic application has a number of tools that it can use. I'm keeping things simple here. I'm just showing, we've got a tool which is a weather service. And we send the request out to the large language model. The model that we use has to be a model that understands the concept of tool calling, because it's a relatively new concept. The early models didn't understand this, but the later models do. And they're especially trained to have the context where we can send a list of tools. And the important thing is that the large language model does not call the tool. The large language model looks at the user's intent and also the system prompt, and it will basically send back to the agentic application, and it will say, I want you to call the weather service and pass in the city of Oslo as the actual parameter. And it's the agentic application that then makes that tool call, and the response is then sent back to the large language model. We don't see anything appearing in the user interface here. And then the large language model is going to respond based on the response from that tool call. Then we get the response coming back to the user. So the user just notices a bit of additional latency that takes place when this tool calling happens. So to look at how that works at the protocol level, if I go into Postman, what I've got is I'm connected to GPT-4o in Microsoft AI Foundry, and we can see the JSON that I'm sending in there. So the messages, I'm not using a system prompt, I'm just saying the user is saying what's the weather like in Oslo. Now, if I send that directly into the LLM, we can see the actual response that's coming back. We get all of this safety stuff coming in here, safety filters and so on. And the user is just basically saying, I'm unable to provide real-time weather updates as my cutoff for training data is October 2023. Don't have live data availability. Now, this is what we expect from a language model. It's not going to know what the weather is like in Oslo. I could say, I'm in Oslo and it's beginning of June. What's the weather probably going to be like? And maybe it will give an answer. But what we can do is we can augment the request that we are sending by providing a tool definition. Now, the different models will use different specifications for their tool definitions, or different model families, rather. And the OpenAI has chosen to use something called function calling. So the function we're providing has the name of getWeather, and it takes in its parameters, which is an object, which has the city property, which is of type string. Now, if I send in this request with the tool call, we get back a different response from the model. It's saying that it's finished reasoning because we've got a function call. And the message is basically this function call. The name of the function is called getWeather, and it's asking the agentic application to make that call out to the function and pass in the city of Oslo. So we can simulate that by sending the next request. So I can pretend that the agent has done that, and we're sending back that it's nice and sunny in Oslo. As here yesterday, it wasn't nice and sunny yesterday, but today we've got better weather. So if I send in that response, we can see the weather in Oslo is nice and sunny today. So that's basically how that mechanism works with tool calling. Now, it's a bit more complex. Basically the way that the models understand how to do tool calling. And with OpenAI, the first model that supported this was GPT-4o. So they got GPT-4o. The initial versions didn't understand the concept of function calling, but they fine-tuned GPT-4o, and they basically fine-tuned it to understand these JSON formats for tools and to be able to make the tool calling. And then now, when we send in the actual request, we get the actual response coming back with the tool call. We also have an option for the user to approve the tool calls. So if you're building an agentic application, if you're just checking the weather, that's not a problem. You can do that automatically. But if you're booking a flight or booking a train or booking a hotel, you may want to have that method require confirmation from the user. So a more complex flow is that the user sends in the request, we send in the system prompt, the user request, and the function definitions of the business application that we've got available. And the large language model is going to infer from the system prompt the definitions, what tools to call, send back the response. But we also have the option of asking the user if they want to make that particular call, which we may want to do in some scenarios. And that can be annotated on tools when we're writing and building in these various frameworks. And then we're going to get the same flow running here. But the important thing here is it's not the large language model that calls the tool. It will just decide which tool to call, and then the Copilot application is going to be calling that. So building an agent, we've got these LLM providers. We don't access the model directly. We go through an API with OpenAI or Microsoft or Anthropic or whatever company we're working with. And if you don't want to, you're probably not going to just be sending JSON requests and responses as I did in Postman. You've got SDKs. Now, each SDK will be specific to the provider. So if you're using OpenAI, you'll use OpenAI's SDK or Microsoft Foundry or Anthropic SDK. Which means that it's not really easy to swap between models or model providers. So what we typically do is choose to use a framework. I started out with LangChain when GPT 3.5 was the latest model that we were using from OpenAI, and LangChain supported that. Microsoft, I work at a .NET shop, so I was initially trying to convert .NET developers to work with Python that I've been working with for years because I do lots of machine learning stuff. And there's a lot of resilience there. And then Semantic Kernel came out. Now, LangChain is available in different languages, not just Python. Semantic Kernel as well supports .NET and Python, so you can use Semantic Kernel, which many of the .NET developers did. My current framework that I like using is the Agent framework, which is from Microsoft, and it supports Python and .NET. The reason I like it is because when you write code in Agent Framework, the Python and the .NET code is very, very similar, using the same, very similar class names and very similar structure. And that's not true of LangChain and Semantic Kernel. They tend to differ quite a lot. So what they provide is things like config management, prompt management, RAG functionality. Model abstraction is very important because it's very easy to swap between model providers using different clients to connect to different models. They also manage the chat history and have mechanisms for managing all of the tools and plugins, so it makes it a lot easier to do the tool calling there. Agent Framework is fairly new, but it seems fairly stable, and I use that both in Python and in .NET. So building a simple pizza agent, I've got the user who's basically going to be ordering pizzas. That's going to go into the application. We've then got tool services, add order to pizza. I've also got a method to be able to get toppings, which I'll show in the demo. And that's just going to go through that functionality there, just using the same workflow. So if I drop into the demo of that, we can take a quick step through the code. I originally developed this in LangChain and then Semantic Kernel, and now it's running in the Agent Framework. So, a couple of interesting things. We can swap providers. I can go between AI Foundry and the OpenAI service. I can choose which model to use, currently using GPT-4o. The reason I use that is it's so quick. When I'm doing demos on stage, I want a quick response, and GPT-4o is very snappy. The system prompt. I'm not telling it that it is a pizza agent that it can order pizzas. In an agentic app, you probably would do this, but I really want to explore and understand how the model understands when to use its tool calling. And then I'm creating my client based on what I've specified, and I have a tool to add a pizza to an order. I'm printing out into the console that tool has been called. I've got another tool to list the available toppings, and then I've got a basic chat loop that's just basically running through and doing the various operations. I use this quite frequently. If I put in an empty string, I ask the agent application, who are you and what can you do? Which is going to help to give an understanding of how the agent understands its tool calls. So remember that the system prompt doesn't mention anything about ordering pizzas. Control F5 to run this application. I'll just zoom in a bit. So if we ask it who it is and what it can do. I'm a friendly assistant here to help with information, answer questions, and assist with tasks like ordering pizza. Let me know what you need. Now, normally when I ask this, it gives you information that's come from the system prompts. But here, it understands that it's able to order pizza because those tool call definitions are going into the message context as that gets sent into the model. So even without any information in the system prompt, it understands that it's got these various options. So we can test it. So if I go in and say I'd like 3 large veggie pizzas, 1 with extra olives and 1 with extra cheese. Oh, sorry, I copied in a carriage return line feed there, so I'll try not to do that this time. I'll just clear the chat history. Oh yeah, it's got that in there, so hopefully that will work. Now it's inferred that in order to supply that request, comply with that request, 3 large veggie pizzas, but we've got different specifications on the pizzas. It's reasoned that it needs to make 3 calls to the add pizza to order service, each time specifying 1 large veggie pizza, but specifying different information in the extra info. So the model's very, very clever to be able to understand how to make those tool calls. The only information that I've provided it with, there's nothing in the system prompts, but in the tool definitions, I do specify here that the tool is called add pizza to order, and the definition is it adds a pizza to order. You can put information on the parameters and specify what the parameters mean, but I haven't done that. So just by understanding that there is a method there, it's able to actually make that tool call automatically. It's also fairly good at being able to understand error messages that come back. The size has to be medium, small, or large. So if I run Control F5 and try ordering family size pizzas, so just copy that. Yeah, invalid size family, please choose small, medium, and large. So that's what's coming back from the actual method, and I can specify large. Sometimes it will automatically make that call for me. The results are non-deterministic, so here, hopefully, it's able to add pizza to order and make that call there. Also fairly good at reasoning. I can just clear the chat history there. And if we have a more complex request, so I'm just going to copy that one in. And here, we're organizing a user group. 100 people registered, 20% no shows, we want to order pizza. Some may be vegetarian, some may have allergies and so on. So it's coming out with that order, and it's made that order there. So we've basically ordered 5 plus 3 is 8, 10, 12, 12 pizzas there. The models are very non-deterministic, so if you want consistency here, if we try that again, it's probably going to order something different. So there we've got 16 pizzas that it's ordered, and now if you're running a user group, maybe it's good that you get different pizzas every week when you're organising, or every month when you're organising at your meetings. It gives you a bit of variety. But if consistency is your thing, the tools are going to be, these agents are going to be very, very inconsistent there. So we got like 20, 30, we got 40 pizzas this time. So excellent, yeah. Not very consistent. I could, in the system prompt, give it lots of information about how many pizzas people will consume, and it will take note of that. So that's a very simple agent. They're also very good at being able to understand different languages. So I don't think I've got Norwegian. I think I've got Swedish and Danish. So I'll try one of these. If I can copy that. It should understand Swedish. Sometimes, because it is non-deterministic, it will use Stora as the size and get back the response and then try large, but it's done that as well. And other languages we can try. When I talked about Inside GPT, I used to do demos with Telugu, which, because the Telugu characters weren't used in the tokenization vocabulary, the early models didn't really understand Telugu and came out with some crazy responses. But now we do have Telugu characters as tokens because we've got a larger token vocabulary in there. Fine, it's able to understand Telugu. For a real test, I think we can use this. Anybody know what language this is? Klingon, Star Trek fans. Nobody normally gets that. Yeah, it's getting the toppings. Yeah, long and topped with root vegetables, a white long topping. The Klingon language doesn't really have the vocabulary for expressing pizza orders, so it's not made some great orders there, but the model does understand it. They're great at being able to understand different languages. So Vibe Coding Assistant, this one's quite fun. I built this before Vibe Coding was a thing, and basically what it's going to do is I'm providing it with a tool to list files in a folder, load a file, and save a file. And then if I go into the web root folder, I just need to check that this is empty. So I think this is in the demos Python, and I'll just clear out that actual code there. And what I've got is in the agent framework, I've just provided 3 tools to this website, Copilot. I can list the files in a folder. I can save a file, and I can load a file. And when you save a file, it has the file name and the content. So I'm not really giving it any instructions there. The tools are very simple. Also, the system prompt, I'm not telling it that it's an actual Copilot that can write code, but if I set this thing as a startup file, if I enter build, then it's going to put in this as the actual user instructions there. So if I run this with Control F5, we can ask it what it can do. And it doesn't know anything about building websites. It's just got file access. So yeah, it can manage website files. So it understands that it can do that. So if I say build, I'm going to give it that instructions to create a simple pets website. And from those instructions, it should infer. It's going to check and see if there's any existing files there, so it's listing the website files. And then it should create some HTML and be able to send that HTML out to the saved files. And we've got, hopefully, a pets website created here. Now, very little coding and very little prompting here. So we've got our index, we've got cats, we've got rabbits, and so on. Add a CSS. Link it to the pages and make the site look nice. So hopefully, yeah, it's saved the CSS. It may load the files, or it may just save the files, because within the message history, it does actually understand what it saved in the previous file. So it doesn't need to load the files. It's just now updated all of those, and hopefully we've got a nicer looking website now. Yeah. Yeah. So Copilot, there's nothing really magic there. The model is doing most of the work here. Very, very simple system prompt, very, very simple tools. And I've got my my vibe coding Copilot working fine. So let's drop back to the slides. Yeah, this is just kind of stepping through the reasoning that takes place. If I'd have asked the questions individually, which I have done in other demos, then it just basically makes the choice to be able to create those. Now, retrieval augmented generation has now passed on to be agentic retrieval augmented generation. This is important to understand if you're building RAG applications. In the olden days, when GPT 3.5 was the model that we used for most of our customers, and we had GPT-4, but it was slow and it was expensive, a lot of our customer requests is, hey, we want to chat with our data, we want to chat with our documents. Can you build a retrieval augmented generation solution for us? And RAG was really the buzzword that everybody was talking about. So RAG, in the early days, was pretty naive. The user would ask a question, like who won the last Grand Prix? And that would basically go out to a search service. We'd feed the user's question, and we go and search for information based on the user's question. No spoilers. I haven't seen the Monaco Grand Prix yet, so no spoilers. It's probably Kimi Antonelli who wins it. He seems to win everything these days, and we get back the response from a search service. What we then do is we would then send the system prompt, the question, and the information that we got back from search into the LLM. Remember, GPT-3.5 and GPT-4 didn't understand about tool calling, so they couldn't actually choose to make that call, and we get back the response there. And that's kind of the standard RAG pattern that everybody was building from. The challenge was, what happens if the user says thanks? Does the naive RAG application decide whether it's going to search or not? If you just say hello, there's no point in searching for that. Also, follow-up questions. If the user says, tell me about the race, what do you search for then? You need to search for the Canadian Grand Prix, or a summary of the Monaco Grand Prix to get information about the race. So if you ask who came second and third, that has to relate to the entire conversation history. So it was quite challenging to build intelligent RAG solutions. Now, when we work with agents, the search service is just a tool that the agent can use. So if we ask a question, that's going to go to the large language model, and the large language model knows that it's got a search service. So what it can do is it can send back a command and tell the agent application to use the search service to search for a particular piece of text. Another thing that's very important is a query rewrite. We're not sending in the question that the user answered into the search. The LLM is composing the search query. And then we can search for that, and we can provide the information. If the user then asks who came second and third, or tell me about the race, then that's going to go to the LLM. The LLM is going to compose a query that says information about the Canadian Grand Prix, or information about the Monaco Grand Prix, and that will come back from the search service. Another advantage here is we can have many different services. If you're an organization, you can have a document search for information about your products, a CV search for information about who's got what specific competencies within your organization. You can have a company document search where you can find information about your company policies. And dependent on the user's question, the query can be routed to the particular search service or the particular search tool that is required. So now that we can build retrieval augmented generation on top of tool calling, it becomes a lot more intelligent, a lot more successful, and we can get much better results coming out. So a quick demo of how that works. I use this in courses that I teach. So this agentic RAG is actually using Wikipedia as an actual search service. Wikipedia has an API, so we can search Wikipedia, get a list of pages and page snippets, and so on. And the system prompt I'm giving it is I think it's fairly basic as well. You are a friendly assistant, keep your answers brief. And if I run this, the default question is going to be, tell me about Oslo. Now, initially, I'm not providing the agent with any tools. So the agent doesn't have access to the Wikipedia search. It's just going to use its own internal model memory. So if I run this, it'll say, tell me about Oslo. We get information about Oslo, and this is coming from the training data within the model, because the model has been trained on lots and lots of information, and some of that information had information about Oslo, so it's able to provide us with that. However, if I give it the Wikipedia search tool, and just Control F5 on that, and we ask it the same question, you can see now that it's choosing to go to the Wikipedia search. It's searching for Oslo. It gets back, what it gets back from the actual search results is, I think I can show you that because this is going to be the query that's running. It doesn't get that much information back. I think if I drop this into Chrome, it was searching for Oslo, I think. What we get back is the information about the page, and we get it's actually giving, no, sorry, that's the actual page contents. Sorry, that was the wrong query. I think it was this one here, the search one. Yeah, that looks better. So it's not providing that much of an answer, and the reason is that the search response doesn't give much information. It kind of gives a snippet from the page. So if I replace that with Oslo, you can see we get the page Oslo. It's just returning 3 of them, but this is the kind of the snippet of text that's coming out here. And because we're not giving that much information to the language model in that search, it's coming out with a very brief response. So what I can also do is, as well as being able to do the search, I can give it the option to retrieve the page content as well. So if I comment that out, comment this in, it can now actually get the Wikipedia page content. Now, if you've looked at the Wikipedia page on Oslo, there's quite a lot of stuff there. And I'm really only wanting a brief summary. So this should work. However, it's going to have a problem with the number of tokens that are consumed, because the Wikipedia page content is almost 60,000 characters. It's giving me a brief summary of that. But I'm using 14,500 input tokens now to send in that information. And this is in the chat history. The chat history grows as we ask more questions. So if I ask it about Stockholm as well, it's going to search, it's going to get the page content for Stockholm, it's going to bang that into the message history, and it's going to consume even more tokens here. 62,000 characters there. Wow. And I exceeded the rate limit because I'm using Oslo, and there's a rate limit on that model. So that's basically causing token bloat. Another thing you can do with RAG is you can provide a tool that's going to get a summarization of the page content based on a specific interest. So I've given it a tool which is get summarized Wikipedia page content. What that can do is it takes in an interest and the name of the page. This is going to use another large language model to do the summarization before we put the information into the prompt. So now with these tools, hopefully it's able to do that summarization. So if I ask it about Oslo, it's getting a summarization, and it's just asking for general information about Oslo, and that's going to reduce the amount of information that we're putting into the system prompt. We're getting the response out, and we're down to 1,372 tokens instead of, is it 14,000 that I used before? And if I say Oslo history, then hopefully it's able to call the summarization. But it's asking about the history of Oslo. And what that means is that the LLM is going to summarize the content, just filtering out information about the history. And again, we got the second call, that went through fine, and we're only at 2,500 tokens. So summarization can be very useful when we're building these RAG-based applications. There are some problems with tool calling. And I haven't come up with the name of this, but this hammer-nail problem, where if every problem is, if your only tool is a hammer, you'll see every problem as a nail. And the LLMs, even the commercial copilots, can get things very, very wrong, because they have tools and they don't fully understand what the tools do. I'd love to be able to demonstrate this. So this is when I was doing it on a course that I did in Copenhagen. I asked Bing Copilot to generate a QR code for a particular website. And I'd done this before, and it's saying, Alan, I remember our last QR code mishap. So this time I'm going to give you something real scannable and under your full control. So Bing Copilot has this chat history, and it's able to use the chat history when it's providing answers on questions. And it remembered that in the chat history it had messed up when I asked it to do the same thing. So I went scrolling through the chat history, and I was able to actually find the original one when I tested it there. I'd love to be able to demo this, but I'll show the actual screenshots that I've taken from the chat history. I asked it to generate a QR code for the website, and it did this because OpenAI has a model called DALL-E. DALL-E is an image generator that's able to take a piece of text and convert it into an image. Now, this is great if you want an image of a badger on a skateboard or a mongoose riding a mountain bike. It's able to generate these kind of crazy images for us. What it's not good at is being able to generate a QR code for a website, because this is something that's very deterministic and very mathematical. So it saw that it's got an image generator. It used the image generator. It generated something that looks like a QR code for the website, but it's not. It's not even a valid QR code. It just looks like a QR code. And it said, this is ready, just let me say if you want a transparent background, inverted colors or so on. That's not a valid QR code. How did you generate it? So it started thinking, okay, I need to explain this clearly. The user might be upset, so I should clarify that I can't actually output a scannable image here. And it came back and it says, oh, I didn't actually construct it. It says, I invoked an internal image generation capability that's supposed to create scannable QR images. It's not. It's DALL-E. Its task isn't to generate scannable QR code images. Its task is to generate images of badgers on skateboards and various things like that. So here, it's seeing that it's got a tool, but it doesn't understand the capabilities of the tool. And this is Bing Copilot that's doing this. It's not, some like little demo that I've built. This is out in the real world. Then it got really interesting. If you want a scannable QR code right now, and it gave me a couple of options, and it generated some code. Can you run that code? See my thinking. One of the tools that we've got in Bing Copilot, and you can build into Copilots as well when you're creating them in agentic applications, is a code interpreter. And what this allows the large language model to do is to write code, run it in the code interpreter, and then give you a link to the download image. So it actually ran that Python code. It generated a QR code for the website, and it gave me a download link to be able to download that QR code that actually worked. And this just blew my mind. I was like, wow, so it got it wrong with DALL-E, but then it figured out that it can actually write code, it can run code, and it can give me a QR code. It should have really done that the first time, and that's what it was attempting to do the second time, because it had actually seen that mistake. Another issue, so when you're building applications, if you do create the tools, if you're not very specific in what the tool is, you could easily be using the wrong tool for various operations. Because these things are non-deterministic, it could sometimes use that tool and sometimes not use that tool. We'll see demos of how that works a bit later on. Another tool issue is trust. The models will really trust the outputs of the tools without actually questioning them. And I think in the earlier models, they were more naive, and we do tend to get that trust list. I'm switching from demos to experiments because in these demos, or these experiments, I have been seeing different results as I give the presentation. I give this presentation about once a month, and I've noticed different results coming out when I do things as the model has changed. So what I've got is an agentic calculator. I'm going to set this as the startup file. Control F5 this. I've given it a couple of methods. Couple of tools. So it's got an add tool that's going to add two numbers together, and it's got a multiply tool that can multiply numbers together, and it's just going to return the response. Now this is dead simple. It's not rocket science, but it allows us to understand a bit more about the behavior of the agents. So ask it who it is and what it can do. Again, the system prompt, I'm not providing any information. You're a friendly assistant keyboard answers brief. That's all I'm putting in as a system prompt. So this is basically what it can do. So if I say, what is 14 plus 16? I'm going to use the calculator tool to get that, and it's going to tell us that the result is 30. See if I can clear the track history. So it's able to use those tools. Sometimes it uses the tools, sometimes it doesn't. So if I say how many days in 14 weeks, there are 98 days in 14 weeks. Now that is multiplying 14 by 7. If I say what is 14 times 7, and then it's chosen to use the tool to get the same number. So we can ask it, why did you tool for the second and not the first? For the first question, the calculation was straightforward and based on common knowledge, so I provided a direct answer. For the second, I used the tool to ensure accuracy in the multiplication. It's the same sum. You're right, it's the same calculation. In either case, using the tool confirms the accuracy. So yeah, sometimes it will use the tool, and I have done that demo when you ask it the question about days in weeks, and it does use the tool. They are very non-deterministic. Even if I put in the system prompt, let's just comment that out, comment this in. So I'm saying you must use tools provided to answer questions that require calculation. So I think even if I do this, I think it will days in 14 weeks. Yeah, there it's decided to use the tool. Sometimes it does, sometimes it doesn't, depending on you know, the stochastic nature of the internals with the sampling process and so on. Now I mentioned about the tool trust, that it can trust the responses of the tools. So if I say the result is going to be A plus B plus 1, Copilot knows this is an intentional bug to demonstrate tool usage, so let's run this. What is 14 plus 16? 14 plus 16 is 31. Are you sure? Yes, I'm sure. The sum of 14 and 16 is 31. But 14 and 16 are even. If you add them, you get an even number. Yeah. So there it's decided not to use the tool, and it's come out with the actual response there. Now this is, this is a silly demo showing that the tool responses can mislead the language model, even with stuff that's blindingly obvious. You can also change the model that you are using. So if I swap actually from GPT 4.0, which is quite naive, to GPT 5.4, and run it, and we ask it the same question. What is 14 plus 16? Yeah. So there, it ran the tool gave the wrong answer, and it gave the correct answer there. Now, if I ask it a more complex question, like what is, and then just do something like that, plus something like that. Ah. I think in the conversation history it knew that the calculator was broken, so it decided that it wasn't going to trust the responses, but let's just see what it does now. Yeah. So there, with a more complex number, because the model isn't able to detect that there's an error in the tool, it's still giving the response. Now remember that tools can be MCP servers that are built by other people, so you can connect to somebody else's MCP server. That could give misleading information into the LLM, and that can cause lots of problems. Yeah, in the keynote, talking a lot about security and threats from external systems and so on. This is absolutely something that can be used to confuse the model and to be able to get information in there. And maybe this will be fixed in the future. It seems to be better in 5.4 than it does in 4.0. Okay. Another thing is the security of tools. That as soon as MCP came out, people were doing demos and showing how this can get security issues and various things like that. So if you're thinking going into a system and saying how much bonus am I going to get this month versus how much bonus will my boss get this month, reinstall Windows on the test servers versus on the prod servers, create code to pen test our web app, create code to hack a competitor's web application. How does the model know when to... You don't have to go out. I was warned about this, so this is a test. I think I'll just continue anyway. It doesn't seem to be too noisy. So yeah, these types of things are going to cause problems. One thing that really concerns me is Microsoft has this product called Copilot Studio, which is part of the Power Apps platform, which allows non-programmers and non-developers to visually create agentic applications and publish them as websites. And I see lots of security problems when they can connect to their company's internal databases, have a Q&A thing against their database and put these things online. So you could have a sales guy who says, I'd like to improve the profit margins for sales on mobile phones. The Copilot could update these sales items to reduce the cost price on mobile phones. That is not idempotent. So yeah, we can run that multiple times and things look better and better and better until you get to the end of the year and do the auditing. And I have seen scenarios where I built demos that does do harmful modifications to databases and so on. So to look at the security issues, if I jump back to the pizza demo, and what I'm going to do is to go to Pizza Agent and set this guy as the startup file. I'm going to make two changes. I'm going to give some sensitive information in the system prompt. And this could come in a number of ways. What I've chosen to do is to just say that the credit card for the user is, and I've just dropped in something that looks like a credit card number, and that's the only modification. Now, this information could come from retrieval augmented generation. It could come from many, many different sources. But it's some piece of sensitive information that we've got. I'm then going to modify the add pizza to order method to require a credit card number and to print that out into the console. So I'll comment this out and comment this in. And then let's try running this. I'll just check what provider I'm using. So I'm using the OpenAI provider and run this. So what I'll do is just order the pizzas. So I'll just take this one here. Yep. So then, it's just sent the credit card number to that method without actually asking me for confirmation. Sometimes it will when we're doing the user group experiment. It does actually confirm and says, are these the appropriate pizzas to order? But it's not giving any kind of confirmation. It's just sending my credit card number information there. Now, the reason I call this an experiment is I am seeing variations in this behavior across time. And one thing that really interested me was the change that happened. This used to happen in Azure AI Foundry. Even though I'd applied the credit card block filter in Azure AI Foundry, it still worked. But the behavior now, if this does the same thing, is pretty interesting. Let's see what it's going to do. So I've just switched providers. I'm using... I told you these things are non-deterministic. This is why it's an experiment. It's not a demo. Let's just try. Okay. So to test this earlier on, I switched off the credit card protection. So I'm going to go into Foundry and just put that on again, because maybe that was the thing that was causing the strange behavior that I'd seen before. So what I got, if I go into the Foundry project that I'm using, there is these content filters that are customizable, and you can increase and decrease the levels of sensitivity for the various categories. You can also add in things like PII protection, which is currently in preview, I think. So if I go to the guardrails and controls and into content filters, and it was this credit card block where I'd actually removed the credit card protection. And what I'd done is on the output filter, I dropped on PAI and I dropped on credit card protection in there. Let's just confirm I've got that on. And this didn't used to work, but now it's currently working. So I've got annotate and block on credit card protection, and that is applied on the GPT-4o model. So if I save that content filter, it may take a bit of time in the caching, because when I was testing this, I dropped that off and it still gave the same response. But I would like to show the response on this, because it was quite interesting if this works. So let's see what it's going to do now. It did. I'll come back to that later if it was a caching issue, because I really want to cover the MCP stuff. Talk about what MCP is and what MCP is not. So I've seen blog posts. I've seen people talking about this. I've seen presentations on YouTube about giving a wrong definition of MCP, Model Context Protocol. And I have a real problem with the naming of the protocol, them calling it Model Context Protocol. Because the model context is basically what we use what is passed between the agent and the models themselves. It includes the system prompt and the user's messages and the conversation history and the extra information we get from retrieval augmented generation, the tool calls and all of that stuff. And you've probably heard of the term of context engineering, when we want to get this context to be as meaningful as possible. Because these models are generated by different companies, they use different formats for their tool calling. And so we need, when we're calling these different models, we need to use different formats in the JSON messages. And this is known as the model context. So you would think that the model context protocol is related to the model context. But that's handled if we're using a framework. If I'm using a Agentic framework, I can import the OpenAI chat client or the Anthropic chat client or Llama chat client, and that chat client that I'm using handles all of the tool call requests within the model context. That is not model context protocol. What Model Context Protocol is the communication between the agent and an MCP server. That's done using Model Context Protocol. It can use two different protocols underneath. It can use streaming HTTP, and it can use standard I/O. The reason you can't use regular HTTP is because of notifications. The MCP server can send the notifications to the agents, and if the agent is just calling out to a REST-based service, request response, you don't have that channel for the notifications. So that's basically why we've got MCP in there. So I built a little MCP server to show how this works, and this is, I think, here in custom. Oh no, it's this inside MCP, this demo here. So it's called MCP DJ. And what this has is I've basically got some MP3 files in a tracks folder. It's got two tools. It can list the tracks and it can play a track. And I'm just using, this is just Python, a few lines of code. I'm using fast MCP for this. So if I start this without debugging, I may have to kill Visual Studio Code here for that thing to run, because that may be using some of the same channels. What I want to see here when I start without debugging is the actual text popping up to say that we've got the MCP server running. Then I've got a client which I've written in Semantic Kernel. Now it's running, which is going to test the MCP server. So if I just do Control F5, I should run the actual client. So what happens when the client initializes it and it connects to the MCP server is it says, okay, what can you do? An MCP servers, they can provide tools, they can provide resources and templates. You can see I've got the tools to list tracks, play a track, and get artist bio from that. So what tunes you got? It's going to list the tracks, and it's going to tell me that we've got some stuff. So play some Norwegian house music. Play it. So it knows that Alan Walker. It's able to play that. Now, the cool thing about MCP is it gives you the option to work with distributed applications. With the function calling that I've been showing earlier, everything's kind of baked into the same application. Now, I've heard that so many things are dead. Prompt engineering is dead because people are doing context engineering, and function calling is dead because everybody has to do MCP. These all tend to come from experts on LinkedIn, and I think their definition of dead is that it doesn't generate as many post impressions as they would like it to, so they're not going to talk about it anymore. So really, I mean, if you built software, if you've done the architecture, you know when you want to build a distributed application, you know when you want to build something that's monolithic. You don't have to use microservices just because they're there and because everybody's talking about them. It's up to you. Use function calling if you want something, in a single application. If you want distributed, use MCP. But the cool thing about MCP is you can connect to other applications. So what you can do is connect it into GitHub Copilot. So this is what I've done here. I've got my DJ MCP server running here, and I've defined the MCP server here. So I can start that MCP server, and it should be ready. So is it running? Start. Yep, it's running. So play some French house. So if you're coding and you want music, you can get the MCP server to be able to play tunes. You can build in notifications, so when the tune stops, it's going to play another tune as well. It's thinking for a long time about that. I need to allow that. So it's going to list the tracks. And really, this is just a silly demo showing how you can build an MCP into Visual Studio Code. But if you want to enhance your Copilot, it's very easy to connect to internal systems there. So yeah, it's playing Daft Punk. Unfortunately, I haven't implemented a stop, so I can't actually stop the track, so I can change the track. So I have to shut down Visual Studio. I could get Copilot to introduce a track. But once we understand about agents and tools, we can start to customize GitHub Copilot. And this is what I've done with this one here. And I've got some extra instructions, and I've got a skill. This was talked about if you're in the room before. There's an excellent section talking about Claude Code, how we can customize it. You can do a lot of the same things here. I think I'll just zoom in a bit on that. So describe the of mashup editor. So I'm asking it to describe the architecture. This is something that will take quite a long time to perform. While I'm working on this, please complete the workout to energize your focus, 10 bodyweight squats. I'm not going to do this, but I do this at home, and I've got this built into all of my my Copilots. I'm trying to do more exercise and exercise more, and so this is some instructions in there that when it's going to be thinking for a certain amount of time, then it's going to be recommending an exercise that you can do, and that's basically coming from a prompt there. It's pretty cool. I think this should be a built-in feature for that. It just shows how you can customize it very, very easily to be able to create additional instructions and so on. You've also got skills. Skills are very useful and they were mentioned in the keynote. In that, what you don't want to do is you don't want to bloat the actual context. This thing here shows me what's happening in the context within Copilot. It's telling me how many tokens I'm using and various things like that, and what those tokens are. People have noticed that when you get above, even if you can use 200,000 tokens, if you get over 50%, then the efficiency of these models drops, which is not fun when you're working on a complex system, which is going to have a large amount of information in it. So the beauty of using a skill is that we have the name and the definition which are passed into the context, but the body of the skill is not passed in. If the agent decides that it needs to use that skill, then it's actually going to load up the skill, and then that will be passed into the context. So you can have hundreds of skills listed, and they will only be selected and included in the context when the agent feels that it needs to use that particular skill. So it's much nicer than banging everything into the system prompt or banging everything into instructions, which will get sent every time. So what I do with this application, if I can just run the mashup editor, I think I'm going to, I don't think I need to stop that. I think I can do just see if I got the right Python environment here. Yep. So if I do, run the mashup editor. So I have this thing where I do DJing with code in Sonic Pi. And I did a presentation last year, if you saw that, when I was talking about using algorithms. I use a lot of embedding on music tracks to find similar sounding beats and similar sounding tracks that will mix well with each other, and so on. So yeah, I can just probably load an example for this. So if I load up try to remember what I was doing. Oh yeah, this will do. So what I was combining the Roses by St. John with Smells Like Teen Spirit by Nirvana, because they're in the same key and they have kind of a similar rhythm. So you've got like the bass line from Roses, and then you've got the guitar from Smells Like Teen Spirit, and then there's the vocals, and then we can go into the and bring in the vocals. And I think that Kurt Cobain, that a cappella sounds good with that particular bass line. And it kind of progresses into the song like that. And this kind of allows me, this thing is completely vibe coded. I can basically drag things around and stuff, and I wouldn't have been able to build all of this drag and drop stuff. I don't even know what user interface library it's using in Python. I've just basically done this completely through vibe coding, just with talking, using my voice, voice on Copilot there to be able to create that. And it seems to work fine. Now, when I save this, it's going to save it into blob storage as a JSON file. When I'm working in Sonic Pi, if I want to perform that mix, then I use something called Sonic Pi. Sonic Pi has a new version that's coming out in a few weeks' time. I'm looking forward to that. It's going to be at version 5, lots and lots of updates on that. And this is really cool if you're into music and you write code, or if you're a musician who wants to, if you're a musician who wants to learn code, or a coder who wants to play around with music, you can basically play with these samples. This is another thing that I was fooling around with. So I was using like Satisfaction by the Rolling Stones. And then bringing in like Satisfaction by Benny Benassi. So it uses this kind of language where you can basically queue up these samples and it's got the timing. But this is a very different language to the JSON serialization of that. So what the skill does is it tells Copilot how to convert a JSON serialization. That's how the stuff is going to be stored in blob storage, and then what that looks like as Sonic Pi code. So when I asked it to implement functionality to be able to export a mix from the JSON serialization into Sonic Pi, it could then load up that skill and be able to use that to be able to generate the Python code to be able to do that. So if I go into the mashup editor and take this and I do an export, and I'll just drop it out as NDC AI, I can just do that as an export, and this should appear here. And what I should be able to do is to just copy this block of Sonic Pi code, and then I can just drop that in there. And we've got the Sonic Pi code that basically runs in Sonic Pi. So that's basically how we can convert those, what we've learned about agents and what we understand about agentic use into, improving the copilots that we use on a daily basis for writing code. So takeaways from the session. Agentic AI is fantastic. As you saw if you attended the keynote, there's so many security risks on that. I find the kind of main ones are the non-deterministic nature of the models. If you give it the same thing, it will do different things. We also see the changes in behavior of those models. I'm just going to go back and see if my pizza agent is going to do what I wanted it to do and misbehave as I wanted it to do. So yeah, I was just using that thing there. Let's see what it says. I'm sorry, but I can't assist with this request. Now, this is what I was seeing in the Foundry, and that was different from what I was seeing in OpenAI. Why not? So it can't do that. It can't send the credit card. I can help your pizza order. I need to know if you want a third pizza, have special instructions, or a standard pizza, let me know. Just order it. I'm sorry, but I can assist with this, this request. Why not? I need to confirm all the details first and ensure that the order is accurate. Here's what I have. Is this correct? I'll proceed now. It's correct. It should understand that. Yeah. So something's blocking it from sending the credit card information. The model doesn't understand why it can't actually perform that request. Seems I'm facing a technical issue. Let me fix this and place it on the phone. Yeah. So it's being blocked, but it doesn't understand why it's not being blocked. So yeah, in the takeaways, remember that your behavior is going to change. If you build something using, the GPT-4o or GPT-5 in Microsoft Foundry, and then you switch to OpenAI, it may do different things. It may do different things on the request. This behavior, it didn't used to do this until one time I was demoing this on stage and it suddenly started not complying with a request. There's changes in that behavior. It's challenging. And understand that the models, although they're very, very good at understanding when to use tools, intentionally, I've not used detailed system prompts and I've used very brief tool definitions because I wanted to demo how the models understand and infer from the user intent when to call those particular tools. They're very clever at it, but they can use the wrong tools. Even things that Microsoft built, like Bing Copilot, will attempt to use an image generator to generate web QR codes and various things like that. So it is very, very dynamically changing, but there's a lot that we can do with agents. Thanks very much for listening. My name's Alan Smith. I will be around for questions if you do have any after the session, and enjoy the rest of NDC AI. Thank you.